All right, how's it going? Today we're going to learn how to particleize any image, and then we're also going to add a mouse effect to it to repulse the particles and then attract them back to their target position. Let's have a look at how to do this with p5.js.
Hey there, WebBay.
All right, here's index.js. Now we have our plan of attack at the top. First, we're going to draw an image on canvas. Then we're going to draw a single particle over the image. Then we're going to map our particles to the image. And then we're going to get the colors at individual image locations, and we'll set that to the particle color. Then we'll work on stretching the image to fill the whole screen. And then we will work on the repulsive forces function, making it interactive and fun. Now let's go ahead and start. You can see right in here, within our project, I have index.js that's in this particle images directory, and that's in our source directory here. And so within that, I also have this webflow.png. This is just an image file that we want to start loading now. So let's go ahead and say let image URL equal to /source/ what was it, particle images /webflow.png is where our image is located. And then we'll create a variable to hold our image and just call it image. Now within our preload function, this is where we'll set our image. So we'll call load image, and we'll pass the image URL just like that. And then down in setup, we want to create our canvas. So we'll call the create canvas function, and we'll pass window, we'll pass window width and window height to that. Okay, so we've got our canvas, and then let's go ahead in our draw function. We'll draw a background with a grayscale color of 40, and we can also put our image on the screen. No, I don't want the capital I want lowercase I. And we'll pass our image and then coordinates 0, 0 for that. All right, and now we can see that we have our image displayed on the screen. So good start. We have finished step 1, draw the image on the canvas. Now let's move on to step 2, draw a single particle over the image. Great, so let's go ahead and get started. We'll define a particle class. So class particle, open close curly brackets, and now our constructor. Our particle is going to need to have an X and a Y position and a color just to start. So we'll say X, Y, and color. And then within the constructor, we'll set this.x equal to our X value. We'll set this.y, so our current instance particle Y value equal to Y. And this.color will be equal to color coming in. These are all coming from the function parameters up here. So we've got our constructor. Now we know that particle is going to have an update function of some sort. And it's also going to need not a darw, a draw function, just like this. And to draw it, we're basically just going to create an ellipse, right? And so we can set our fill. Let's, no, not file list. Let's set our fill to 255. This is going to be a completely white particle. Actually, I'm going to set it to 0 because that W in Webflow is white. And so we want to make sure that we see this circle, and then we'll call ellipse. And now this needs an X and a Y. So we're going to get this.x, this.y. And it also needs a size. Let's set our particle size to 10, just as something we can see. We could define that as a constant up here too. So let's do that now. Const particle size equals 10. And then we'll just change this 10 down here to particle size. All right, save. And so we've gotten draw there, but we haven't actually created a particle yet. So let's go ahead and do that here. We'll say let p, and then we'll initialize p equal to new particle, and that needs an X and a Y. So let's say, let's just set it to something like 70 and 70. The webflow.png is 154 by 154. It's a square image. So this will put it somewhere near the middle. And then we also needed to pass a color. Let's just pass 0. That color would be actually here, this.color we would set in the fill function here. So that's how we'll draw it the color that we want it to be. Okay, so we've created our new particle, and then we just need to draw it down here. So we'll call p.draw just like that, and we'll go ahead and save and see. So now we've got this particle right here showing up on top of our image. Okay, the easy parts are done. Now we want to map the particles to the image. And for this, I'm going to make our own function. We'll call it spawn particles. So spawn particles, make sure I spell this right, particles, just like that. And we're going to have nested for loops in here. But before that, let's make sure we call spawn particles. We'll do that in the setup function because we only need to trigger this once. So just like that, we've got spawn particles. And now let's go ahead and create 2 for loops. I equal to 0, I less than. For here we want to use the width. Let's start by using just the width of our image. This can get a little bit confusing, so we'll keep it as simple as we can. And then we will increment I by 1, and then we also need to create a variable called j. Let me add let in front of I there. Let j equal to 0. J is less than 154, which is the height of our image, and j plus equals 1 here. Now what we want to do is we want to create a particle at each spot there. So we can pretty much get rid of this up here. Let me cut that, and we will say new particle here. And what we want to do is we want to add these to an array. So particles.push, and wrap this in parentheses. And up here, rather than defining p, we will just say let particles equal to an empty array. And then, so we're pushing all of our particles into this particles array. We're going to need to loop over all of our particles. So let's call the for each function on it. And that's going to get each individual particle. We'll use fat arrow syntax to create an anonymous function in here. And then we will call particle.draw. So this is going to draw every particle that we store in that array, which we're storing them in our array down here in the spawn particles function. Now we need to change the x and the y values. So let's go ahead and set the x value to I and the y value to j. And then this was the color. We're making them all black. That's fine for now. Let's save and come over to our project and see what we get. We're totally covering our Webflow image here with black pixels. So that's great. That's exactly what we want, right? But now once we start coloring these, we can go ahead and see them. If I bring this particle size down to 1 maybe, it's not going to change anything yet, but I'm starting to see actually a purple line here. And the reason this is happening is because we're incrementing by 1 every time. So we're still covering. Now if I change this to something like 5 and save, then we can see now we're just starting to get this kind of dotted pattern above of our Webflow image here. And you can see the dots aren't quite lining up correctly. So let's go ahead and fix those two things before we move on. So I like calling this, let's call this something like resolution. Because we could essentially, make our dots match the original image even more with a lower resolution or less with a higher resolution. So let's go ahead and say const resolution equals 5 and save that. So now we're doing good there. Now we notice these are kind of setting the origin point of the circle right to the edge there because we're starting at 0. Now we could offset this by the resolution value or the pixel size of the circle, but we'll worry about that later. Right now, let's go ahead and keep pushing on with our colors. So we've taken care of this one. Let's check that. We've taken care of this one. We've mapped the particles to the image. Now we need to set image color at particle position. So the way we can get the image color is right in here. We can call image.get, and get takes an x and a y value, which we're using here as I and j, and it's going to return to us a color value. So let's say const color equals image.get I and j, and console.log our color. So if I come over here and I open up the inspector, you can see we're getting an object here that's an array of R, G, B, and alpha values. So we can totally use that. I'm going to delete this console log. Rather than making it black, let's set it to color and come back and refresh, and it's not working. Okay, it's not working because what's going on is that our particles are too small and these already have a stroke applied to them. So one way we can fix that is by calling no stroke down here. And another way we could see that better is by upping the particle size to something like 2. Again, and now we're starting to see these particles and there's no stroke. Let me just get rid of no stroke so you can see what was going on. So if we don't have that, then these are getting a black stroke. That's so big, it's taking over the color of the circle itself. So let's keep no stroke on there. We'll keep our size at 2. And now we've got our colored particles coming up there. But the image, we don't really need to draw this anymore. I'm going to keep it commented there. And now we can see we're getting this really cool particle effect. And it's being, the colors of each particle are being pulled from the color on the image at the same coordinates. Now, this doesn't look that great because it's all constrained to its normal size. I think I have my browser zoomed in. Yeah, I do. So let's go back to 100%. So this is what it would look like at 100% zoom. All right, something we can do is stretch our image to window, or actually we'll just call width and height here. And that makes our image stretch, but it's okay that it stretch a little bit because we're, pixelating this thing pretty heavily. But you may want to be careful with stretching some images a lot. But I'm not going to go into how we would maintain the aspect ratio in this tutorial. We'll just go ahead and stretch it out. Now that's just being stretched for when we draw the image, but we're still going to have problems with getting the coordinate points. Like if I change this to width now and this to height, then I'm trying to think of how to best explain this. Essentially, we're just going to get the same result. You can see our pixelated Webflow logo is still way over here. Now I'll open up Chrome DevTools, and what I'll do is I'll just go ahead and console.log the color again. And so what we'll see is we're getting all these arrays with all 0 values, so completely invisible or transparent pixel in this case. And what's going on is that the image is still just 154 by 154. So any positions over here are actually transparent. Now it doesn't look transparent because we stretched the rendering of the image over the width and height, but it actually is transparent here. And we're still loading. It's going through all of those pixels, and then it loads, and now we can see. Okay, so here's what we need to do is we need to basically just transform our coordinate system. Boom, boom, ding, ding, that's the answer. And what we'll do is we want to get the coordinate between 0 and 154, but we want to map that to the width and height of our canvas. So we can define a value called x, and we'll just take our I value and divide that by the value of width, and then we'll multiply it by image.width, which again is 154. And we'll do the exact same thing for for y, and we'll divide j by the height, and we'll multiply that by image.height. Okay, so this is now x and y are image coordinates. So we want to get the color at that specific coordinate, but then we want to map it to a particle on our screen from I to j. So we'll go ahead and save that. And I'm going to get rid of this console log here because that delays things. And now we get our pixels mapped to the whole screen. And I'm going to kind of make this a little bit prettier by upping the particle size to 5. And we'll keep the resolution at 5. How is that looking? That's looking pretty cool. Let's go ahead and up our particle size to 10 and our resolution to 10 just to make sure that we don't run into any issues with lag. And I think this is what I did for the demo. Okay, I think that's looking really good. Now we can see if we shift by particle size divided by 2 when we draw, we should probably be pretty good at that point. So let's go ahead and say particle size divide by 2, particle size divide by 2. And now we've got a great looking grid of particles. Let's check in with our progress. So we set the image color to particle position, and then we stretch it to fill the screen. We're making great progress, but we have probably the most difficult part before us now. We're going to repulse the particles from the mouse. This is all going to be handled within our update function. So let's be sure to call that here before we call draw. So particle.update. And now we'll define our update function. Just to give us a little roadmap, I've got some comments here. So our very first task is going to be to get the vectors for the mouse, the target, and the current position. Essentially what we're going to do is we're going to have a vector that points from the mouse to the current position of the particle, and another vector that points from the particle to the target. And we're going to create a repulsive force for the mouse and an attractive force for the particle, for the target. And then we are going to add those forces together to create a net force, and then we'll affect the position based on what that force is. So let's go ahead and do that now. So we'll say mouse vector equal to create vector, not create canvas, create vector. And this is going to get mouse X and a mouse Y. And then we'll say we'll call it current vector equal create vector. And that's this dot X and this dot Y. And then we'll also have a let target vector equal create vector of this dot target X and this dot target Y. Okay, so we've got our vectors. Now we're going to just look at the mouse vector and the current vector in this case. So let's call it let from mouse to particle equal p5.js vector. So this is a function from the vector library. And we're going to call .sub for subtraction. And we're going to subtract the current vector from the mouse vector. And now we want to get the magnitude of that, which will represent our distance. So let distance to mouse equal from mouse to particle dot mag gets the magnitude, which is going to be our distance in this case. Now we're going to do the exact same thing here between the target and the current particle. So we'll call this from particle to target. And rather than passing current vector here, we will pass the target vector, and we'll pass the current vector, and we'll call this distance to target. And we will take this value and paste it down here. So doing the exact same thing, but with two different particles this time, or two different locations and vectors. Now, if the mouse position is within 100 pixels, so we'll say if distance to mouse is less than 100, then we want to start calculating some sort of repulsion force. And the way we can do that is we'll say let repulsion force equal, and here what we're going to do, we're going to use the map function, and we want to map the distance to mouse. So that's the variable that we're looking at here. And we know that that distance is anywhere from 0 to 100. And then we want to interpolate that to values anywhere from some sort of maximum force value to a minimum force value. So we can call this max force and min force, but we need to define those. I'll go ahead and copy this, and we'll define them all the way up here at the top of our project so we could edit these if we wanted to, you know. And min force equal to 0 actually. Okay, so we've defined those. We can come back down to our map function, and that is good to go now. And then we will set our, so now what we want to do is we have that vector, right, our mouse vector. So from mouse to particle dot set mag, and we're going to set that magnitude to the value of repulsion force here. So this is getting a number value anywhere between 0 and 10 based on the distance of the mouse to the particle. And then we're just updating that vector magnitude to be whatever that value is. And then we also need to track this within a total force vector. So let's create a new total force equal to create vector. And that's just going to be a 0 vector. And we'll say total force dot add from mouse to particle then. And if the mouse is not at the target, we need to calculate an attractive force to get it back in position. So very similar to what we had above. In this case, if it's greater than 0, then what we want to do is have an attraction force. And we want to map not our distance to mouse, but distance to target. So let me grab that. And we're going to need to swap the min and max forces here because it is being attracted now. And we'll set the from particle to target value to the value of attraction force. And we'll go ahead and add that to the total force as well. So now total force is acting like a net value. And the final thing to do is call this dot x equals to total force dot x, and this dot y, actually plus equals is what we need to do. Definitely don't want to set that equal to total force dot y. Okay, a couple things before we run this is that we have the subtraction function here where we're subtracting inside of it, but this actually takes two parameters to subtract. So it's going to do the vector subtraction for us. We can't use the minus sign there. The other thing we need to do is that we have this dot target x and this dot target y, but we never actually defined those within our constructor. So we'll set our target x to our initial x value and this dot target y to our initial y value. And then lastly, anytime you copy paste, you got to look out for copy pasting and not updating your variables. So right here, we need to take from particle to target and put it here in our add function. So let's save and have a look at what we've got now. So now we can see we've got our really cool mouse interaction hovering, and the particles are all going back to their original location. All right, that was fun. We have completed our plan of attack here. I hope you have some fun playing around with these parameters and seeing the different kind of effects that you can get. I'll upload a version of this to Webflow and update this image URL as well as the canvas to make it just a little bit more responsive, and make sure that we're pulling in our image from the Webflow uploads. And that's really it. You know, if this was a lot, then I would encourage you to check out my previous video on a simple particle system, the networks and drawing lines. Once you can get a handle on that, I think this one will become a lot easier. Anyways, if you enjoyed the video, as always, like and subscribe, and I'll see you in the next one. Bye bye.